Our title today is Writing Formulas from Names. So today we're going to go the opposite direction. We are going to get the name of the compound, and then from the name we will write the formula. We're going to do all three types of compounds today. The first thing you've got to keep in mind when we are writing formulas from names is the very basics about these particular compounds. An ionic compound, metal, non-metal, is the way we recognize something as being an ionic compound. And when we are writing a formula for an ionic compound, we have to keep in mind that it is an electrically balanced compound. The total number of positive charges from the cation is going to equal the total amount of negative charge from the anion. Covalent compounds, we recognize them. They are non-metal bonded to non-metal. They are not electrically balanced compounds. Their stability comes from sharing electrons, not from opposites attracting. And Greek prefixes are used in names, so we're able to go backwards and translate those prefixes into numerals in a formula. And last but not least, we've got acids. And we recognize an acid because the cation is hydrogen and it is bonded to a nonmetal. Acids are electrically balanced, meaning that the total amount of positive charge is going to be equal to the total amount of negative charge coming from the. Our first compound is magnesium chloride. And in my mind, I'm going to say, okay, magnesium is a metal, chlorine is a non-metal. This is an ionic compound, so that means my total amount of cation charge has to match my total amount of anion charge. So I'm going to go to my periodic table and I'm going to look up magnesium. The symbol for magnesium is Mg. Go to the periodic table, and the symbol for chloride, chlorine, is Cl. So the next thing I need to do is I need to figure out what their ionic charges are. Magnesium has an ionic charge of +2. I'm going to get that off of the periodic table. Chloride has an ionic charge of -1. So in order for this compound to be electrically neutral, my total number of positives has to equal my total number of negatives. And so that means that for every magnesium, I'm going to need 2 chlorides, MgCl2. That is the formula for this particular compound. Let's try iron 3 oxide. The formula for iron is Fe. The formula for oxide, oxygen ion is O. Oh, look at this, it's iron 3. So it's giving me its charge. +3. The charge on an oxide ion is -2 from the periodic table. It's not as simple as this one, where I just need 2 of them, right? I've got +3, -2. And so what I'm going to think of is their least common multiple. Their least common multiple is going to be 6. So because of that, I am going to say Fe. Now if their least common multiple is 6, 3 times 2 is 6, positive. So I'm going to say 2. And for the oxygen here, negative 2 times 3 is negative 6. And so that's going to balance the 2 out, right? If I have 3 times negative 2, that's negative 6. If I have 2 times positive 3, that's positive 6. And so my cations and anions balance. I'll show you a little trick once we've done this for a little while. A shortcut for it, but I don't want to do that yet. Last but not least, we've got lithium phosphate, our last example. Symbol for lithium is Li, off the periodic table. Phosphate we have to have memorized. We have that. PO4. Okay. So our next step then is what are the charges on these things? Lithium off the periodic table is positive 1. Phosphate off of your ion cards that you have memorized is negative 3. So how many lithiums do we need to completely balance this phosphate? We need 3 of them. So it is going to look like Li 3 P phosphate. There's another one I want to do real quick as well. I want you to try it. Let's go, I'm going to go 2 pages over. Let's try calcium hydroxide. Go for that real quick and see if you can do that on your own. So pause the movie and see if you can do that one on your own. Symbol for calcium is Ca. The symbol for hydroxide is OH. Charge on calcium is positive 2. Hydroxide is negative 1. So for every 1, I need 2. So here's the thing with the polyatomic, is that if you are going to need more than 1 polyatomic anion, you've got to put that polyatomic anion in parentheses. So it's going to look like CaOH2, meaning that you have 2 hydroxides. All right, so that's it for ionics. This compound is a covalent compound. How do I know it's a covalent compound? Because it's got these Greek prefixes. And so this is going to go very, very easily. Sulfur, chloride, trisulfur. Tri means K. Tri means 3. Hepta. What's hepta mean? Hepta 7. S3Cl7. Ooh, isn't that easy? That's a nice one. All right, so that's covalent. Those are pretty straightforward. Okay, let's go with the acids. So how do we know this is covalent? Again, because because non-metal, non-metal. Our first 4 examples, metal, non-metals. Okay, we knew they were ionic. We know this is covalent, non-metal, non-metal. All right, let's do our last one. Okay, this is an acid. How do I know? It says it in its name. So if it says it in its name, I know what the cation is. Automatically, I know that the cation for this thing is going to be a hydrogen. Now, we have to work backwards with this thing. Hydro. Oh, I shouldn't have. I'm going to follow my example. So my cation is hydrogen. Now, if we go back to our rules for naming acids, if it has a prefix, that means that the anion has no oxygen. If it has a prefix, the anion has no oxygen. So if this is hydrofluoric, that means we've got fluorine itself. That's it. Over here, barely. Okay, so now I need the charges for these things, and I didn't leave enough space here to really do this. So I'm going to do it over here. What's the charge on a hydrogen ion? It's a positive 1. What is the charge on a fluoride ion? It's -1. How do I know that? Periodic table. And acids are electrically balanced. I've got +1, I've got -1. So the formula for this thing is simply going to be HF. Did I leave a little more room? No. Sad. Let's move you down. Let's get you out of the way for now. Okay. Nitrous acid. We know the cation is hydrogen. Oh, there's no prefix. Nitrous. So that means it's an oxyanion. Us is ite. So that means this thing is nitrite. So then, what's the charge? Hydrogen, +1. Nitrite, -1. It's an acid, so it is electrically balanced. And so our formula for this thing is going to be HNO2. All right, let's do one more. Let's do this sulfuric. I'm going to get rid of this. Sulfuric acid, hydrogen. Sulfuric, no prefix, no hydro. So that means we have an oxyanion. Ic means 8. So it's sulfate. SO4. All right, what are my charges on this thing? Hydrogen, +1. Sulfate, -2. It has to be electrically balanced. So for every 1, I need 2. So my formula will be H2SO4. Okay? Okay, let's practice.